Show that two lines intersect and find the point of intersection.
Yep.
That is the learning objective of what we're learning today. So now, let me write the equation of the two lines first. I'm going to call the line L1 and L2. So the first line is L1. L1. So the equation for the first line L1, I'll write it out. 1 minus 3, 2. Plus lambda minus 3, 2, 4. So that's the equation for the first line, L1. And then the next line, L2. Five minus 10 minus 11 plus mu 511. Right. Can you see the two lines clearly?
Yeah.
Okay. So when you finish writing that, let me know. Okay, so now the first thing we want to do now is to write these two equations because there are two lines. We want to write those two lines equals to each other. So we would pick the one from the first L1. We will have 1 minus 3 lambda. Then multiply the top part. Because each of them, since the lines intersect, imagine the left side, the L1 is equals to L2. So we want them to make them equals to each other and solve it. So before I start writing that, I would say the intersect. So L1 is equals to L2. That means line 1 is equals to line 2, and then you solve to find where they intersect. So you make them equal, and then you solve to find mu. We solve it to find mu, and then we can check if it's correct. So we make the two equations. Remember this arrow there, I'll rub one of the arrow. We can write this arrow as X, Y, Z. And that other arrow there, we can write it as X, Y. Does that make sense?
Yeah.
So now we make the two lines equal. So we can work, the first one will be 1 minus 3 lambda. And then minus 3 plus 2 lambda. That should be equals to, for the other side, 5 plus 5 mu. That's one side for L1 and the other side for L2. The next one, minus 3 plus 2 lambda. Minus 3 plus 2 lambda. And then 2 plus 4 lambda. So minus 3 plus 2 lambda, that should be equals to minus 10 plus mu. And then minus 11 plus mu. So we got 3 equations there. 1, 2, 3. So we need to solve those 3 equations. So because we have equation 2 has got mu in it and 3 has got mu. If we subtract them, mu will disappear. So we can do equation 3 minus equation 2. So let me write it out. Equation 3 that's equation 3 minus equation 2. Put a line there. So the 3 is at the top. The 2 is at the bottom. So the minus, I'll put a minus at the end here in the pink. So that means 2 minus minus 3. This will give me 5 there. 4 minus 2 lambda gives me 2 lambda. Minus 11 minus minus 10 gives me minus 1. Mu minus mu gives you 0. So when you solve this now, you can solve this for lambda. So that means 2 lambda is equals to minus 6. And lambda is minus 6 divided by 2. Lambda is minus 3. When you get up to that part, let me know. So to find mu, we're going to substitute lambda is minus 3 into equation 2. So I will take equation 2 again. And I will take equation 2 again. And what I will substitute into equation 2, I will substitute, I'll put lines to point at it. I'll put lambda is minus 3. So that'll give me minus 3 plus 2 times minus 3 is equals to minus 10 plus mu. Want to solve it for mu. So minus 3 plus 2 times minus 3. 2 times minus 3 is minus 6. So minus 3 minus 6.
Minus 9.
So it's minus 9. It equals to minus 10 plus mu. If you add 10 to both sides, that will mean if you take, that would mean 10 minus 9, so mu is 1. You happy with that?
Yeah. Yeah.
So now that we got mu and lambda, we're now going to use equation 1 now because we haven't been using equation 1. We're going to use equation 1 to check if it is correct. We have used equation 2 and 3 to find mu and lambda. We would take it now to put in equation 1 to check. So you would say sub into equation 1. I'm trying to look for colors that will not clash with this brown. Let's see, it's green and brown opposites. Let's say sub into equation 1. So it'll be 1 minus 3 times lambda is minus 3 is equals to 5 plus 5 times mu is 1. So the left side would be minus 3 times minus 3 is plus 9. 1 plus 9 is 10. The right side, 5 times 1 plus 5 is 10. So the left side is equals to the right side. So they intersect. That's the conclusion. So the lines L1 and L2 intersect. So in summary, how do we show that two lines intersect? We get the equations for the two lines, make them equal to each other, and solve for mu and lambda. And then use that answer for mu and lambda, substitute in one of the equations to make sure they're equal, the answers are equal, and that shows that the two lines intersect. Now, the next thing is to find the point of intersection. So we want to find the point of intersection. So we can substitute mu and lambda in any of the equation. So we know lambda is minus 3. So let's pick L1 and substitute it into L1. So we want to find the point of intersection. We have shown that they intersect. We want to find the point of intersection. So we go back now and take the first equation. This is, we'll go and take L1. We know lambda is minus 3. So put lambda is minus 3. So have 1 minus 3, 2 plus lambda is minus 3 bracket minus 3, 2, 4. So we want to work that out. So the 1 plus minus 3 times minus 3 is 1 plus 9. Minus 3, the next one, minus 3 plus minus 3 times 2 minus 6. So minus 3 minus 6. And the last one will be 2 minus 12. This is, so when you put that all and work it out, you will get 10 minus 9 minus 10.
Yeah.
So that's the point of intersection. So you find where the lines meet, find mu and lambda, substitute lambda or mu in one of the equations, and that gives you the point where they meet. So that's how we do that type of questions.
Okay.
Perfect.